Hello, everyone. Thanks for joining me today in this new session in which we will cover a no-code approach to creating composite scores to uncover spatial insights. My name is Miguel Alvarez, and I'm lead data scientist at Carto. And today, this session is going to be about two very recent components that we added to workflows. In particular, these two that you can see on the screen. One is Composite Score supervised. The other one is Composite Score unsupervised. The first question before starting with the example is to know what are composite scores. Probably when we want to describe our business or how attractive or what's the potential that a specific location has. Normally, we can think of many factors that affect that. It can be demographics, it can be human mobility, many different factors that in the end make it very complex to really identify high value or high potential locations in a specific place. And even worse or even more complex is it to afterwards communicate this to other people. What composite scores allow us to do is combine all these variables that can, or factors that can affect our business in a single indicator or scoring, so that afterwards it's easier for us to explore a specific area or get to different insights regarding a city or a country that we are interested in. This can be interesting, for example, for identifying high potential locations for a new business or to sell a new product or even for investment. And with this, let me show you one of the workflows that we're going to be using. Again, we are going to be presenting today how to work both with unsupervised composite scores and supervised composite scores. We'll start with the unsupervised one, in which basically the difference is whether we have a business metric to compare against or not. In this case, let's suppose we don't have a business metric, and this is the unsupervised approach. So we just know that there are specific variables or factors that affect our business or our decision-making process, but we don't have a metric or a business metric to compare to. Okay, so we just know that there are specific factors that affect that, and we want to explore an area based on those. So in this case, let's start with a use case in which we want to explore the city of Milan, in which we, for example, are interested in expanding a wellness and beauty center business. And for that, we have identified specific variables that affect our business. For this example, we are going to be using spatial features data. This is a data set that is available through Carto's Data Observatory. Let me show you here. This is a data set created by Carto, and it provides demographics information, also POI information extracted from OpenStreetMap, also urbanity and climate data. For our use case, we are interested in 5 main variables or factors that we are going to be selecting through this select component. In this case, we are interested in female population between 15 and 44, public transport, because we think that being closer to bus stations, metro stations, and so forth might attract more people to our businesses. Also, we want to be close to educational POIs. Also, total number of POIs, because we want to be in busy areas where there is human activity. And finally, urbanity. We believe it's also relevant because we believe that our business performs best in very high urban areas rather than low density urban areas, for example. So yeah, these are the variables that we are going to use. You can see them on the bottom of the screen. These are the variables that we have. As you can see, we have 4 numerical variables from female population to total number of POIs, and we have 1 categorical, which is urbanity. So the first thing that we need to do is we need to transform this variable from categorical to numerical, because we are going to combine them, and we are going to do this using this case when component that we have here. The idea is, again, that what we are going to be doing with the case when component is transform the different categories that we have into a number. So in this case, for example, we are transforming the very high density to 1, high density to 2, medium and low to 3 and 4, respectively. And this later allows us to combine them. Okay, then, well, we are just going to drop the urbanity and we are just going to keep the new one that we are calling urbanity ordinal. And with this, we are already ready to create this composite score. So let me explain you the different options that we have. In order to create an unsupervised composite score, we just need to decide how we want to combine those variables. As you can see, we have 3 different methods. We are going to be using the custom weights, which is probably the most well, the easiest one to understand, the most, and the one which we can influence the most from a business point of view, because, well, we basically select the variables that we are interested in using or combining in this case, and we can provide weights. So, for example, in this case, we would be saying that female population is 5 times more important than the urbanity index, for example, and 2.5 times more important than the total number of POIs. This depends on our use case. We can select different weights here. But as you can see, there are other methods. For example, we have first PC. This uses principal component analysis behind, and what it takes is the first principal component. And we also have entropy. In this case, it would select the indicator based on the information provided by the variable. So again, in this case, let's select custom weights because it's the easiest one to understand. And then one interesting thing is that we want all variables to go in the same direction, meaning in this case that the more female population we have, the better. The more public transportation POIs, the better, and so forth. In this case, if you remember, with urbanity, we defined very high urban areas as 1 and low urban areas as 4. So we want them to be reversed because we want them, again, the higher the number, the better. And we can select that by clicking on this. This is why we see this arrow pointing down. The next thing we need to select here when we are creating one of these indices is the user-defined scaling. In this case, this scaling is how do we want to transform the variables before combining them. So normally the most well-known one, let's say, is the min-max scaler, which basically transforms all variables to a scale of 0 to 1. And afterwards, they are combined. But we have many more. So, for example, we have the standard scaler, very typical as when. Ranking, which is the one we are using here. With what this does is it ranks all values of its variables from 1 to the n, so the number of observations that we have, and then combines them. So this is what we are going to select. But then, as you can see, we have many more. So when we are done with the session, I'll show you where you can find more information and all the documentation necessary to know all the details about these possibilities. So in this case, we are using ranking for normalization, and afterwards we can select the method in order to combine them. In this case, we have linear, which will do an arithmetic, in this case, a weighted arithmetic mean, or a geometric mean. So that's it, what we have. And finally, we can select the output formatting. If we select none, basically, so what comes out of this combination based on the options that we have selected before, this is what we would get. Normally, that is going to be a little hard to interpret, and we want people to, we want our scoring to be easily understandable. So we can select other options like equal intervals. In this case, our index would be discretized into a number of intervals that we would select the number of intervals that we want. We can also select quantiles or jenks, same thing. So we would be discretizing this because sometimes it's easier from a business point of view just to have 4 or 5 buckets, for example, meaning from very low to very high. So it's easier for people to understand our scoring, the scoring or the ranking that we are creating. For us, in this case, we are selecting return range, which keeps the continuous variable. So we're going to have a continuous scoring, but we are transforming it to a range from 0 to 1, so it's easier to understand. So in this case, we know that 0 means very low potential or attractiveness in this case, and 1 would mean very high. And with all these options, then we are going to create this index that we can visualize here in the unsupervised. I've already created a map where we can see the results. And in the meantime, let me quickly show you that here in the Carto Academy, you can find this same workflow template that you can download and run it yourselves. All the data is publicly accessible, so you can run the exact same example that we are running now. You also have a supervised one. And the most interesting thing that you can find also here is that under this advanced spatial analytics section, you have step-by-step tutorials under the spatial analytics for BigQuery. And you have one section which is how to create a composite score with your spatial data. Here you can find a very, very detailed guide that will guide you through all the options that you have when creating a composite score. So all the options that I showed you before, it's explained, so you know when to select one or the other. So let's see how the map is going. So in this case, let's this load. So this is the result of our scoring. Let me open the legend as well so we can see. So here, this is the scoring that we created. In this case, as you can see on the legend, we have a scoring that goes from 0 to 1. We decided to split to create 5 buckets here in this styling, so that we want to know those with scoring larger than 0.9. That would be the most attractive. So in this case, we can see this large area here in the city center and then up to the northwest. And then, well, we have some other isolated areas that could be also of very high potential. One of the things that we can do also in Builder is, for example, we can create this a widget in which we are identifying the top potential quad beams. So, for example, this is sorted by the scoring that we just created. So we have here the 5 top quad beams. So, for example, if I select the first one, I can see what is the area of Milan that, based on the business knowledge that we have inputted into creating this index, so the weights that we have assigned, this would be the most attractive area for expanding or for opening a new beauty center in this case, or a new store, or for investment. We can also add a filter like this one. For example, if we are interested in only locations with more than 0.95 score, we can filter it. We can see that the main areas are here in the city center of Milan, and then here in the northwest of the city center. So right now, as you can see, we started from 5 different variables that probably show very different information if we analyze one by one. The idea here is that we have combined all that information into a single scoring that allows us to explore the city in a very easy way and a very interpretable way, because, well, we have a potential score. Everyone understands what a potential score is. And then we can add some filters that help us explore this area very easily. So this is what we call unsupervised. And now this in a lighter way, I'm going to show you how to do a supervised scoring. As I said, the main difference between supervised and unsupervised is that in supervised scoring, we do have a business score to compare against. Okay, so basically in this case, let me make this bigger. If I zoom in here, we will have the same data that we had before. So we have these spatial features for Milan, where we have for quad beam 18. So for every, let me open this. here, if I click on data, so in this case, again, so I have the same information as we had before. So female population, public transport, education, POIs, and so forth. But then I have this, what we called label data, or a business metric is what we have. And in this case, this business metric can be anything that is relevant to our business. In this case, we selected the different in performance or in sales before, so pre and post COVID. So what we are measuring is how fast or how good we are with regards to how we were pre-COVID. But it can be any other thing. It can be just revenue, the revenue from last year. It can be the number of tickets that we sold. It can be anything that represents a business metric of our interest. In this case, what we are going to be doing, or what this spatial scoring does behind the scenes, is it trains. All you can see here, again, the template is available. But basically, what we do is combine these two data sets. We select the variables of our interest, and here the interesting part is the final, the last but one component, which is the one with the composite score supervised, in which we are going to select which are the variables that we want to take into account for building this index. As you can see, we are taking the revenue change, female population between 15 and 44, public transport, education POIs, total POIs, and urbanity. And what this does behind the scenes is actually training or fitting a predictive model. Okay, so with all the external variables, we are going to try to predict what's this revenue change. Here the different options that you have depend on what, in this case, since we're using workflows for BigQuery, so we can go to BigQuery ML and see the options that we have, which is what you can add here. As you can see, this has to be written in a JSON format because this is very open. This is open to what BigQuery offers. In this case, what we're going to get is, again, a different type of index, because what we are going to be doing is fitting a model, making a prediction on that revenue change, and we're going to compare what the model says against the actual value. And this means basically that if the actual value is better than what the model is performing, that means that that location outperformed or is performing better than what was expected. So in this case, that the revenue change was better than what was expected based on the model, and the other way around. If it's worse, then it means that it's not recovering so fast from COVID, let's say. In this case, again, for bucketization, so we decided, in order to make this simpler and easier to understand, what we are doing is that we are creating 5 buckets that are centered in 0, so that we can easily identify, and I will quickly show you in this map. So we can easily identify those areas that are performing or are recovering from COVID as fast or as good as expected. But then we have 4 other areas. 2 of them, which will represent the areas that are recovering much better than expected and better than expected, which in this case, you can see that we identify them in the north and west of the city. And then those areas that are recovering worse or much worse than expected, which in this case, you can see that they are here on the west of the city center, somewhere in the south, and also on the east of the city. So again, this index is very, very powerful, because in this case, we are comparing what, from a business point of view, we know that affects our business. Then we have a business metric that is what was the recovery, or what's the difference, or what's the revenue change from pre and post COVID, so that we can see, okay, how good can we predict that, and then how far away we are from that prediction, and that will represent how good or bad, if we are overperforming or underperforming what should be expected based on the factors that affect our business. So again, very powerful. This again gives us very powerful information of what are the dynamics that are happening in a specific city. This provides a lot of information from a business for investment, for opening new stores. For example, in this case, I know that these areas here are recovering better, so probably here is where I want to open a new store. And with this, this was the idea of today's session. So to give you a brief introduction to composite scores, both supervised and unsupervised in workflows. I hope this session was helpful and insightful. And again, you can find documentation and examples in the Cart Academy website. So hopefully we'll hear from you. So thank you very much.